Good morning, everyone. It's good to see. We know, as always, those people with very busy diaries are piling through the door at 9 o'clock. So we'll give them that sort of 30-second introduction period of time to try and get in before we start formally. It's really good to have you on board this morning. There's no doubt about that, and we're grateful for it. This is Industry Wales and ASTUTE 2020 coming together to really present, perhaps, and this is a little concerning for some of us, but perhaps a window of opportunity that still exists today, but we can't be certain will exist tomorrow. And therefore, this is a real good chance to be able to explain the sort of innovation support that ASTUTE is able to do, bringing us into productivity, sustainability, competitiveness for the future itself. So as I can still see people piling through the door, I'll keep talking in that regard without getting on to anything vital right now. So happy St. David's Day. I guess that was 2 days ago, so I perhaps should say happy Budgets Day, and most of us will be watching the other screen most of the day to ensure that we get something significant as regards Wales and innovation and technology and engineering, etc. on it. So I'm going to just wait for that to click over to the 90, and then I'm going to start bright and breezy on the agenda today. We can see that that over the last 12 months, I mean, for many of us, it's been unprecedented, hasn't it? I think many of us have been through different crises in our industries, in our sectors, global economy, recessions, these type of things. And all of the time, in those periods of time, we've looked to see what we can do differently to ensure that the future can be managed well, whether that's personally or professionally or for the company that you work for, the company that you perhaps own and lead itself. And there's no doubt that the last 12 months have done that, with an additional thing that we've not really known how this will work forward. We've also not known even month by month what the impact will be. And it's been significant for many small industries and even larger industries to understand how they can progress and sustain themselves in this period of time. In the middle of all that, thinking differently, thinking innovatively never has been more important. We know that we have sort of pandemic, we have Brexit, we have just the natural requirement of being more and more competitive week by week, day by day. And therefore, the whole thinking needs to be different as to what we do. Now, people will sell us tools and sell us different things, or ultimately it comes down to the way that we think as regards continuous improvement. What can we improve day by day? How can we improve it? What are the ways that we can improve these things? And that's realistically what we're talking about today. And that is thinking differently about how we can be more competitive for the future, no matter what the circumstances or the context of what we have behind us. And manufacturing, to me, and I came back to Wales to do this, manufacturing is the bedrock of what our economic future is for our future generations. We need to make things, take responsibility for making them, make them competitive, and ensure that actually we can bring rewarding employment in that area itself. So I make no apologies for that, and I never do. Technology, engineering, and manufacturing, I feel, should be the most significant thing that we do. And that means actually working through different sectors. Perhaps COVID-19 has taught us that single sector activity is sometimes very difficult, and we might need to look to see how we engage with different types of sectors. All of that will mean change. All of that will require continuous improvement. All of that will require innovation on your behalf. And what can we do to support that? Very happy today, therefore, to take the session for ASTUTE 2020 as regards one of the major innovation enablers that we have within Wales to bring to your company. Now, we're going to take about 40 minutes of presentation, 45 minutes of presentation, and then we have many questions. We were up to 41 questions even before you start loading them up to the Q&A on here today. So we're a little concerned. However, the commitment of the panel today, as I introduce them in a second, is that every question will get answered, and both the recording of this will be available and a written answer will go to the discrete questions that we have today. So we'll run through presentations, an overview of ASTUTE 2020, and then talk about driving competitiveness, 2 video case studies from local manufacturing companies like Ladders and British Rototherm, and then continuing on with continuous improvement and sustainable materials from my panel here. I'll introduce them as we get to them one by one to save a little bit of time. So without any more, other than to remind you that you've got the Q&A there, that you can use to put questions as you go through, and we'll address those in the last 25 minutes. And to remind you that it is being recorded. That doesn't impact you too much, but to remind my panel also that it is being recorded. So when we get very emotional, as I do occasionally on certain subjects, then I'll make sure that I remember that recording is ongoing at this moment. So I'm going to introduce the next speaker and start with Professor Hans Seitz of Swansea University to give us an overview of ASTUTE 2020. Thanks, Hans.
Good morning, everybody. Thank you, James, for introducing. We'll see the slide in a moment coming up. So we'll briefly introduce ASTUTE 2020 Plus. ASTUTE is a partnership which has been working since 2010. It stands for Advanced Sustainable Manufacturing Technologies, and key is, and looking at Paul's early question about how can we do things differently, ASTUTE is, although we've been operating since 2020, we've been 2010, we've been transforming as we go along, morphing, developing new technologies, new areas of expertise to respond to the need of industry, but also to address future challenges which we see coming up. And part of ASTUTE, we do horizon scanning exercises to make sure that it's fit for purpose, what we deliver. And naturally, the discussion, the engagement with industry is very important to shape what we do and we can deliver. Since 2010, we have developed quite a number of successful collaborations with industry. And in the first 5 years, it's the only evidence we've got so far. We generated over £200 million of economic impact in West Wales and the valleys. And we're looking forward to the next evaluation, which is due shortly, to see the kind of economic impact the collaboration with industry has generated. Next slide, please. The support which we provide to the community working with industry is clearly in the field of research, development, innovation. We are looking at competitiveness, productivity, and future-proofing of work, of companies, of businesses, to make sure that the society can benefit from the economic impact those companies produce. Key is really to talk to each other, to develop, stimulate new ideas, and it's always fascinating talking with companies. Sitting down, when we bring our expertise and our knowledge to the table, companies bring their knowledge and expertise to the table. Something new always will come up, and I think it's this dialogue which is very, very important. Naturally, once we go into project delivery, there will be quite extensive knowledge exchange between companies and ourselves, and that's at the heart of ASTUTE, that the bi-directional knowledge exchange, where we learn from companies and we can share our knowledge with companies and leave it behind at the companies. The collaboration is industry demand-led, and it's also looking at de-risking new technologies, trying out new things, which might be at the early proof stage, to make sure that when companies would like to move in a certain direction, or there's a gap which has been identified, this can be explored with the help of point-wise support by the ASTUTE project. We're looking at transforming what is being done. And Paul made a point there about the Made Smart testbed, which radically changes how we look at supply chains, for instance. And maybe this knowledge is something which can be brought into the ASTUTE project as well as part of the delivery mechanism. Growth is naturally very important, but in the current time, it's getting back to where we were is most probably the more important aspect where we need to get at. Next slide, please. The benefits which the ASTUTE team can bring into the collaboration is we've got academics, they've got a lot of experience in doing research in very relevant areas, whether it's materials technology, whether it's Industry 4.0, whether it's data analytics, whether it's robotics, whether it's polymer processing. And we've got dedicated teams of highly qualified researchers and technical experts who complement the expertise and are the key people in delivering the joint projects with the companies. Naturally, we will use our state-of-the-art facilities, which we've got. We've got experimental equipment, we've got experimental software. We use naturally commercially available software as well. But sometimes the problems are very complex, and it's only when we go to some of our academic researchers say, do you have a piece of software which can solve this tricky problem? And frequently there are cases which you can only use bespoke in-house software to solve that problem. The projects will be jointly developed with the companies naturally, and it's very important. And on our side, we've got a dedicated technical manager who then delivers jointly with the companies the project. So it's this joint collaboration and project delivery, which is key, which hopefully makes the collaboration smooth and easy to move forward. Next slide, please. The ASTUTE focuses on manufacturing, and manufacturing could be all aspects of manufacturing. On the right-hand side, you can see a number of companies which we've been working with. The collaborations, number of collaborations we've done over the last 10 years are well into the hundreds. This is just a subset of the companies we work with. The manufacturing focus, then we try to group into three large groups, which one is advanced materials, computational engineering, and manufacturing systems engineering. I don't want to delve too much into it, but they're quite wide-ranging definitions, and you'll see later from the presentations by my colleagues, David, Gavin, and Mo, that some examples and also from the companies, what is meant by this. But basically, if you are unsure, just give us a call and we'll see whether this is something we can engage with you and can support you with. Next slide. The projects are all collaborations and two collaborations in the sense that the companies and the ASTUTE team will work together on quite a number of issues and technical aspects. We share the input, so we expect company to provide staff time, sometimes then materials, equipment, and we'll do the same on our side. Depending on what the project needs. So key is really that the project is clearly defined and set up and planned. So when we come into the delivery, all the resources have been set aside and the project can be delivered smoothly. So again, this is really a dialogue with the company. We'll define then work packages, we define deliverables and milestones to make sure that it meets the industrial time scale as required. The outputs and outcomes of it are IP, know-how, products, processes, and anything else you can think of. Naturally, hopefully the companies then go further with this and they exploit this for their commercial benefit and profit. We share the risk. So again, it's this coming back to the point I made earlier about de-risking. Sometimes as it is happening with research, it might not deliver what you expect. Sometimes it will prove actually what you thought might work will not work, which is an answer, not quite what you looked for, but certainly an answer, and you then can close down this avenue of investigation and as a company can go elsewhere. So we all this will be shared. We share then the outputs in proportion of inputs. Very importantly, that each partner brings their own input to the table, but no cash exchanges hand. So we don't expect any payment from the company to ASTUTE, and ASTUTE naturally doesn't have finances to support the company. So that's very important. We all have our own work packages with our own costs. Important point might be that the company can naturally use the inputs against R&D tax credits. And we had a presentation about this by a tax consultant. And again, we can point in the right direction if you would like to know more about this. So very importantly, ASTUTE is a partnership and of the universities which you see at the bottom there, Aberystwyth, Cardiff, Swansea, South Wales, and Trinity St. David. And jointly, we deliver this program working with companies across Wales. Next slide, please. There's a lot of information on the web which goes beyond what I've been saying, including contact details. But if you want to browse around on astutewales.com, but also please look at the project spotlight. Some of this will be presented now, but there are more on the website for you to have a look and get a feel for the kind of collaborations. At which point I'll hand back to James.
Thanks, Hans. I'm getting the feeling that I was about to say it's good to talk. I guess that's an advert that goes beyond most of the people online here. But I think this is one of the things that I find is that this is not perhaps a project that you know the answer to. This is something that you need to discuss and find, if you want, ideas, whether they are ideas that will work or don't work. And I think that's the first place to do with these things. You might not yet know, and it's good to see Don's question in there as regards it's open-ended in you. What on earth could we do with that subject? That is something that will improve our competitiveness. That was something that will improve our process. It's something that will improve our product, etc. It's good to talk, and I think that would be the first place of it. In essence, is that ability to talk to a group of people in the first place. But I'm delighted now to introduce Professor Mohammed Naim. Now, Mo is a good friend of ours here, and he's got something called Smart Specialist Leader. I always wonder about leaders who've got the word smart in it all, but there we are. Mo, I'm going to hand over to you here because I'm passionate on this one. How are we going to drive competitiveness forward?
Thanks, James. Yeah, we've got a little pre-recorded clip here. So. Good morning, everybody. My name is Mohammed Naim. I'm the lead for the Manufacturing Systems Smart Specialization in ASTUTE 2020. I'm just going to highlight some of the challenges we've all been facing during COVID and relating those challenges to some generic opportunities and then showing how those generic opportunities can be applied within specific organizations via case studies. And thanks to my colleagues, Andrew, Jacqueline and Anthony, who helped prepare this presentation and who are here today during the webinar. What we thought we would do is just to highlight some of the major challenges or some typical challenges that we have faced as organizations during the COVID crisis, and then to translate those into opportunities, some generic opportunities that will allow us to compete both at the local, national and global level. And these are some of the challenges we've brainstormed ourselves with regards to some of the things that organizations have faced during lockdown and post-lockdown. So, for example, to comply with social distancing requirements during COVID, we have to look at ways of maybe laying out the factory differently or reconfiguring our factory differently. We may not necessarily have the physical movement of assets, but the way we manage our working and the way we do things might change. Another example is obviously automation to avoid people actually handling components and equipment. So perhaps moving towards this vision of the Industry 4.0 fully automated factory. Also, an example is more recently organizations looking at developing new products to meet the needs of the nation and more globally as well, with regards to introducing new products like PPE. We worked with organizations in terms of helping them develop and manufacture visors, face visors, and overalls, and maybe not through ASTUTE, but through other means. We've also been working with organizations in the foods and drinks industry, and drinks industry in particular, looking at translating the production from making alcohol to drink into alcohol for hand sanitizer. One of the things as well that organizations are facing during the COVID crisis was looking at local suppliers, especially due to the big ramp up in demand for things like PPE, and moving away from global sourcing to local sourcing. And also, as we've all faced during this time, is actually working from home. And we'll look at opportunities now from working from home and how we can help organizations do that in a manufacturing context. So what we have done here with regards to opportunities is just translate some of those COVID crisis-specific challenges into generic opportunities, things we may have done ourselves anyway in order to achieve operational excellence, continuous improvement, but sometimes the crisis actually gives us the motivation to do things more quickly. So for example, with regards to the first one relating directly to the previous challenges for the previous slide. So with regards to social distancing, well, actually, looking at our factory layout, looking at ways to streamline our material flows, our process flows, gives opportunity to improve in terms of reducing non-value-add activities and enhancing the value add throughout our total manufacturing process. With regards to automation and enhancing automation, looking at robotics, for example, to reduce material handling, the opportunities offered by our research in robotics. We can look at ways to reduce the amount of handling actually required by individuals, and looking at ways also for individuals to be working with the robots in a sort of a whole systems perspective. When looking at introducing new products, obviously that gives opportunity then for us to look at how we can become more agile, more flexible, in particular agile in response to volume changes, and offering greater variety in terms of our product range, in terms of what we can actually manufacture, to look at the pros and cons of make to stock versus make to order, and so on. And then in terms of looking at local supplier, well, there's this opportunity for us to look at right shoring the supply chain, looking at where we actually sourcing from, looking at critical products, products that are essential to, or components that are essential to the product that we make, vis-a-vis sort of more commodity type products. And we may look at a supply chain in terms of what can be sourced locally and should be sourced locally versus what we can actually source globally. And then the last one there, just in terms of home working, looking at the opportunity there is really reducing the need for physical office space and assets as well, physical assets. What I'll do now, after this highlighting these generic opportunities, I'll now give you just an overview of some examples, some cases where we've actually applied some of this manufacturing systems, engineering methods and opportunities within specific companies. This gives you an idea of the range of manufacturing sectors that we have worked with. So the first one here is medical devices. This is in particular pumps for bedsore blankets. And in this particular example, the first example, we looked at looking at new layout and in particular looking at new ways of working. And in this case, via gravity feeders for materials handling, so avoiding direct contact in terms of relating it to COVID, avoiding direct contact between operators. And this kind of gravity feed system and new layout led to productivity improvements. The next one is an example of braking systems assembly in the automotive sector, the development of cobots, where we have within the same space both operators and robots, but the main research challenge there is working safely, and in this case with there being no longer a need for robots to be hidden behind cages. The next two examples are both two different companies actually, but both in analytical equipment manufacturers. The first one where we looked at understanding and documenting current manufacturing processes, looking to enhance value-add activities within the manufacturing system, and identifying ways to enhance capacity. So the various modeling techniques we used here, visualizations, process mapping, and computer simulation as well. The second analytical equipment manufacturer, we looked at sourcing strategies as well as manufacturing operations, but in particular looking at a new way of sourcing, not just simply looking at cost or price, particularly for various critical components, looking at how we can enhance the resilience of the supply chain. So looking at the capabilities of suppliers over and above low cost. This was particularly relevant because there were lots of delays with the critical components coming from overseas suppliers. So we're looking at things like the supplier ability, capabilities in terms of agility, flexibility, as well as efficiency as well. The last example, which relates then to the remote working, this one is a joint venture between Cardiff and Aberystwyth with the printing company, looking at the development of an app to be downloaded onto a smart device that allows maintenance managers to work remotely from a specific factory. So allowing them real-time remote monitoring of the production systems to minimize downtime. For example, this maintenance manager had a number of different operations to look after, and wasn't necessarily required in any single factory. Okay. Thank you, James, and look forward to answering questions afterwards.
Thanks, Mo. I hope that I can manage to get off mute then. I think it's quite clear in here that over the last 12 months, we've learned that there are many things that we can bring innovation to, and it's sometimes the mundane, but we were never getting around to it until the days that we had to do it because of the context we were in. And I think that's one of the key things. We know that, for instance, productivity will step change after global recessions. Unfortunately, that quite often means that people find solutions to do things automatically that they were doing manually before. That's just the nature of these things. What we need to do is always do this and get ahead of it. So again, thanks for that, Mo. I'm now going to, I think we have a poll at this point. So Ryan, just help me along on this point. I think you get about 30 seconds or a minute perhaps to answer a poll. Oh, good news from Ryan is that we go straight forward with no poll and we go into the introduction of a case study by Light Ladders, which is a multi-phase research project. It's only a 2-minute video. So I think Ryan, with that, we'll go straight into it.
My name is Chris Loynes. I'm the factory manager of Light Ladders and Towers based in Swansea. Light have been manufacturing a range of glass fibre and access equipment for over 65 years. We initially approached ASTUTE back in 2012 and have been collaborating with the team ever since on various research projects. This allowed us to develop and understand pre-welding processes and exploiting ASTUTE's 2020's research expertise to further our own knowledge. We had difficulties in optimizing the robot welding process, resulting in a high number of defects, costing time, money for the business. ASTUTE 2020 were able to support us with their expertise in advanced materials, computer modeling, and manufacturing systems. The collaboration has assisted us to move from manual welding to more sophisticated automation for ladder manufacturing and scaffold towers. As a direct impact of the collaboration, we've been able to increase our workforce, employing 7 new people. We have been able to expand our existing product range, as well as introduce new products to the market. The knowledge and understanding of our manufacturing challenge and the research conducted by the team allowed us to have confidence in the project being delivered successfully. Without ASTUTE's 2020 support, we wouldn't be adopting advanced manufacturing technologies so quickly in order for us to improve the welding division of the business to ensure a long-term future for the company in West Wales and the Valleys. It was great to know that his expertise right on our doorstep in Swansea. We've had a great experience with working with Swansea University, and we'd like the sort of partnership to continue.
That's great. We appreciate that. Now I'm going to keep pushing forward here, and I'm great pleasure to introduce Professor David Gethin to speak on continuous improvement today. Over to you, Dave.
Hello, I'm David Gethin, and I'm going to talk to you about the modelling opportunities offered by ASTUTE 2020. We all understand the challenges that industry faces these days. These challenges can be associated with new products and processes which are there in response to the market demand. Other challenges that are faced are those associated with developing new in-house technologies to improve the self-reliance of businesses and their innovation platform. The challenge of looking for design for manufacture and sustainability, and the challenge of designing processing systems for environmental impact. On the next slide, we'll set out how ASTUTE 2020 can assist in addressing some of these challenges. ASTUTE is a brand that's been working with Welsh industries for a period of around about 10 years. During that period of time, we have worked with businesses to support the development of new products, to support development of existing products, and to support development of process capability. And we can point to a number of successes in each of these areas. In modern terminology, we are there as ASTUTE has been able to create virtual twins of the product or the process, and that can then be used by business for decision making. ASTUTE offers opportunities to undertake computational modelling, and the expertise in ASTUTE can be set out under three main headings. Those are structure mechanics, whereby we deal with statics, transient, dynamic, and modal analysis. In fluid dynamics, where we deal with mixing, separation, phase flows of fluids and gases. And the third area, which is thermal, electromagnetic, and acoustic. And of course, we can bring those all together into complicated multiphysics modelling. And these have been used quite successfully to reduce prototyping cycles to enhance product and process performance. We will now look at two industrial case studies that have been undertaken by ASTUTE. The first is aluminium tray forming, where the challenge is to form a perfectly rounded bead on the edge of the tray so they can be processed successfully in subsequent packaging operations. The second is laser trimming of a reverse extruded aluminium can, where the wavy edge around the top of the can must be removed by laser machining, and any particulate that is formed must be removed from the can. We now look at the example of aluminium tray forming, and essentially it comprises three steps: deep drawing, wiping, and curling. Deep drawing is the way in which we manufacture the body of the tray itself, and this is a complicated process in that you have to have a large deformation of what is an originally flat sheet of material. There is contact between the punches and the dies, and there's friction there. And again, these parameters need to be incorporated into this part of the deep drawing module. The wiping stage is whereby we take the flat edge formed at the top of the tray and bend it over as a wiping cycle. And that bent over edge in the curling cycle is then rolled over to form the bead at the top of the tray. The next slide will show an animation of this process. This slide will show you the animation of aluminium tray forming. The sequence will show you the deep drawing and the wiping and the curling stages of the process. It'll all appear very much as a sequence of complicated and controlled tool movements. This slide shows the outcome from the tray forming simulation. And inset, we see an example of the defect on the rolled edge. In doing this work, ASTUTE worked very closely with the business partner, and at the end of all of this, identified three potential solutions to address the problem of the tray edge defect. These potential solutions are now being carried through and tested further by the company. This is the second industrial case study, whereby we're looking to trim the reverse extruded aluminium can. It's a two-stage simulation. The first stage is the laser trimming itself, whereby we actually generate some debris, particulate debris, And the second stage is to look at the flow and ventilation in the can in order that we can remove that debris from the can prior to it going on to the next stages in operation. This slide shows an example of the laser cutting process. It is a complicated process to simulate in that it has a multi-phase flows, i.e. it has liquid phase and gaseous phases present. It is complicated by virtue of the fact that there's a melting taking place, and if melting takes place, then the material properties are clearly temperature dependent as well. The model also has to account for the energy that is deposited onto the surface of the workpiece by the laser itself. What we can see here is a laser beam radius, which is typically 50 micron, to give you an indication of the size. And what we see in the animation on the right-hand side of the slide is the penetration of the laser into the workpiece and the removal of the particulate from the workpiece as it goes through. This slide shows part of a parametric study into the ventilation of the can in order to remove the particulate. It should be noted that in this study, the can itself is rotating and that a gas jet is directed across the can at 0 degrees, which is across the diameter of the can, or at 15 degrees or 30 degrees, which is there to introduce a level of swirl within the can itself. The model is complex, it's multi-physics, in that there's a particulate phase and a gas phase, and that the two interact. And the aim of the study is to look at the way in which the gas phase will cause particulate movement out of the can in order to clear the can of debris. This slide shows the outcome of the parametric study presented in the previous slide. And what we see here is that, generally speaking, at 0 degrees, 15 degrees, and 30 degrees, there is little benefit in that around about 48 to 51% of particulate remain within the can. Needless to say, there are other parts of the parametric study which showed that this was there was an effective method of particulate removal, and further work is ongoing at this time in order to improve the understanding of the ventilation process. So the outcome of the work on laser machining and can evacuation has developed what is really a process virtual twin. And that has aided the understanding of a challenge that has been in existence for a period of around about 7 years. Complementary to this is the fact that the MD noted that this approach to solving this problem should have been taken place much earlier. And the company is now actively pursuing the opportunities that has been provided from this simulation study.
Thanks, Dave. I always love that presentation. I've seen it once before, Dave, and I love it because it's the bit that you don't say. All the people online are going, well, why did you do the parametric study that showed no difference? Why didn't you show the one that made the big difference? And I guess that relates to one of the questions about the confidentiality of it all. The bits that really made the difference are the bits that Dave can't show you, because that's what the company's IP is an advantage is right now. So I'm grateful for that. And we're going to move forward now into another case study by British Rototherm. And again, this will be highlighting the computational modeling activity on this particular issue itself. Thank you.
I'm Oliver Conger. I'm the Managing Director and owner of British Rototherm. We're a 170-year-old organisation, and we manufacture precision instrumentation that measures temperature, pressure, level and flow. I heard about ASTUTE 2020 from an organisation called Make UK, and they connected us with the right people in ASTUTE. They've got a very strong technical understanding, especially around computational fluid dynamics, which was crucial for what we were trying to study as part of this program. The problem we were trying to solve was, what is the noise emitted through one of our restriction orifice assemblies? As pressure flows through one of these devices and it drops, it creates noise, and the noise can also lead to vibration and potential problems or rest of the pipeline. There is nothing available for restriction orifice plates. So we wanted to come up with a proven model that we could then take to designing a better product. So from Astute's side, they came in, we broke down the problem into a number of different steps. And together with our own team, we put together a project plan to be able to come up with a model and be able to test that for the restriction orifice plates. And so what Astute ended up doing, they helped us prove the model, and then that model was tested through some pretty sophisticated CFD software. The orifice plates that we were selling now were designed on a proven formula for noise, which nobody in the world has. And from that, we were able to go to our customers and prove to them that our design was able to meet the noise requirements. And what this has led to is been a number of significant projects we've been able to secure worldwide, and also resulted us in being able to employ a further 5 people in the organization and invest in additional machinery to really put us as a leader in this field. So the reason for working with Astute 2020, they have a significant amount of technical capability. They have access to programs and software and resources that a company such as Rototherm doesn't have. They can help provide confidence to take something that you may not have gone forward with. So since we've completed the project, we've been working with the M2A program. So we have a student here for 4 years. We've got a proven model for calculation of noise through one of our devices. And that has led us to now bid on projects. And it's resulted in us winning the largest ever order for this particular product line for Vietnam. So it's been a super success.
That's great. I mean, Oliver, Tarquin may be online. I don't know. So I know I've missed an email from Tarquin yesterday. So Tarquin yesterday, which I need to catch up on. But, you know, these are really examples of doing something significant as regards global leadership on some of these things here. So thank you for that, British Rototherm, today. We're going to move forward again to try and maintain an agenda here. And we're pleased now to invite Dr. Gavin Bunting to talk on sustainable materials. Ultimately, when we talk about sustainability, and we know that we need to take more and more carbon responsibility ourselves, not purchase carbon, not procure everything, but take responsibility ourselves. Ultimately, that will always bring us back to materials. So delighted, Gavin, if you can take us forward from here.
Thanks for the introduction, James. As with Mo and David, I've also got a pre-recorded presentation here available.
Hello. I'm Dr. Gavin Bunting, Deputy Director of Astute and Associate Professor in the College of Engineering here at Swansea University. So today I'm going to give an overview of some of the world-leading materials research support available to companies collaborating with Astute. So Astute has the capability to work with companies on a range of different classes of materials, from metals and alloys, polymers and composites. We can examine and evaluate microstructures and measure microscopic properties as well. We also have the capability for additive manufacturing of different materials. So I'm going to give an overview of the facilities available and end with an interesting recent case study. So to start with, optical microscopy. We have a range of optical microscopes, the one pictured here being the Kientz VHX1000, which produces an image with around 20 times the depth of field of conventional microscopes. It also combines stepper motor precision with fast image processing to capture a series of images, focusing through the sample height range, leading to an in-focus image of a 3D surface. And also allows for 3D profile measurements such as volume, distance, or angles to be measured up to an accuracy of 1 micrometer at a magnification of 1,000 times. Optical microscopy can be performed on cross-sections of materials, and we have state-of-the-art capabilities for metallographic preparation as well. Scanning electron microscopy. So we have 3 SEMs, each with different capabilities. And electron microscopy allows us to achieve more detailed resolution, with this one pictured here having a resolution of 0.8 nanometers. You can look at uneven objects, such as fracture surfaces, something I have significant experience on, spending a lot of my PhD analysing fatigue fracture surfaces of critical aerospace alloys. You can also evaluate metallographically prepared surfaces as well. The SEMs are also equipped with energy dispersive X-ray analysis, which can reveal the chemical composition of, say, different phases or inclusions. In addition, there is also a focused ion beam, which can accelerate ions to selectively mill out areas of a sample to study composition variation as a function of depth. X-ray microtomography. So this allows 3D imaging of materials within a structure. So the research from this facility produces some really interesting images. A couple of weeks ago, the BBC showcased the work of Professor Richard Johnston in digitally unwrapping mummified animals from ancient Egypt. And the image here is showing the product of this research. So you can get full 3D imaging of structures that are below the surface. So that's it on the microscopy side of things. Next, I wanted to highlight our metal additive layer manufacturing expertise and facilities. So a lot of you will be familiar with 3D printing, and as well as your common polymer 3D printers, we also have state-of-the-art metal additive layer manufacturing, which prints directly from metal powders. This can achieve very intricate shapes that can't be produced by traditional casting techniques. 3D printing can cut material consumption and CO2 emissions within certain applications. It can also support design optimization and is useful in low volume production scenarios, such as spare parts for an aircraft where they're printed to order. So automotive, aerospace, defense are currently the largest manufacturing sectors using this technology. However, it's also now being used within dental printing, medical implants, and device printing and product creation. This is an example of one of the ALM machines, Renishaw machines. It works by a bed of powder is laid down, the laser scans the surface and selectively melts powder particles that correspond to the region of a component. It's built up layer by layer as more powder is deposited. Unused powder can then be removed and reused. We also have a post-processing facility called a hot isostatic press, which provides a combination of high temperature and high hydrostatic pressure to close up any residual porosity. So that's it on the facilities. Next, I really wanted to highlight, okay, what's the current pandemic pose for kind of material selection and materials challenges? It poses challenges for us all. There's some specific materials challenges associated with COVID-19. For example, the need for sterilization of products or other cleaning techniques to be applied. Need to consider implications for the materials. Will they withstand temperatures and/or chemical agents used? Need for antimicrobial products and coatings. New ways of doing things post-COVID may lead to demand for new products. Also, as one would expect, there is need for more advanced medical products and devices, and it is an example of this I want to highlight next. So Corona Event 1. This case study provides an example of how ASTUTE rapidly responded to urgent need for manufacturing a prototype ventilator. The ventilator was built quickly from local parts and can be used even for patients with severe coronavirus. It was built within 10 days from locally available materials and skills. And I've got a video now showing this.
The Corona Event 1 was built in 10 days from commonly available materials and using locally available skills. It has the minimum possible number of specialist medical parts. It's completely optimized for the types of lung problems seen in COVID patients. We're currently developing Corona Event 2. The differences from the initial prototype are that it's splash proof, the gas now enters through this port here. The check valves can be any design that you have available. The exhale gas comes through this diaphragm valve, which again can be made by 3D printing. It can be machined from stainless steel. If you wish to clean the inspiratory side of the system, the bellows unit unclips on the inside and the whole thing is extracted through the end here. So the entire gas pathway can be dismantled for cleaning, but particularly the expiratory side is just this part here, which comes off very quickly.
So I think that was an interesting case study showing how we responded quickly and efficiently to produce a prototype ventilator. So to summarize, we have leading edge materials analysis and characterization facilities supported by world-leading academics, and we can work with companies responding quickly and efficiently to help them innovate and develop new products and services. Thank you.
Thanks, Gavin. I was back on mute. That was my fault. Those of you who are seeing the Q&A, I'm trying to actively answer Q&A at the same time and actually saying hello to a few as you're going along. So I'm grateful for that. Now, we finished the presentations, and it's always frustrating at that point because there's so many things that we could present, but rather we're going to go into the Q&A session for about 20 to 25 minutes. Invite you still to do the Q&A, and there's a bit of network going on in there as well. There's some pleas not only to ASTUTE, I'm sure, if you've got experience as a company out there on doing certain things such as Clara, etc., don't be afraid to put that up. It's part of the benefit for us this morning on it. But we have a series of questions. There were 41 before we came in. We've got a further 15 here, 3 that we haven't attempted to open. 3 of the questions that have been asked this morning are such a level we'll be here all morning on them. So we do commit to do written answers on these things, but I think some of them, practically speaking, we'll have to get together to have further dialogue on. I'm going to start with the question today. We all need help. It's similar to what Marcia has put into the Q&A today. We all need help during the current climate crisis. Is there sector-specific help available? Each industry will have its own challenges. Now I'm gonna pitch that straight to Mo to start. He doesn't know that bit, so his face will drop at that point, and I might come in to support that one as well. Mo, if I can hand that to you first.
I hope we've identified through our presentations and through the little case studies that we've given quite wide range of sectors. As you see, we're not sector specific. People say manufacturing is a sector, but it's arguable whether it is. It's actually made up of a number of different sectors. So we've seen there sort of medical, engineer, high value engineering. We've done work in the food sector and so on. So we've got quite a wide range of different sectors. The key thing is that we collaborate with the partner. So it's an academic partnership with industry, and we jointly co-create, co-design the project. Okay, I think that's the critical thing about it. We try to understand what the problems are. We do a very thorough analysis, and then we deploy the best approach to solve any particular problem. So it's tailored. It's very much tailored to the specific requirements. I think the key thing as well is because we're not sector specific, we can look at learnings between one sector to the other. And so there's very much learning opportunities between sectors, looking for generic solutions, but then those solutions adapted to your particular circumstances. So I hope you got an idea of the scope and the spectrum of different sectors we've been working in.
Thanks, Mo. Hans, you want to come in quickly on this one?
Just to add to what Mo already said very clearly, we've got expertise in the teams. We've got expertise in a wide range of fields, whether it's food-regulated products like medical devices, and if needed, we've got the capability to bring in other expertise to work with us under the ASTUTE framework to collaboratively work with companies.
Thanks, Hans. Now, I don't know where that question's from. Probably I could track that back at some point, but I'm going to just put some context around that as well. This is the ASTUTE activity this morning, and I have no doubt that they will be able to talk through different issues with you. In case you're talking about some other support mechanisms, such as furloughing or safe working, testing or simply, investment for the future. There are a number of different parties on board here this morning, particularly from Welsh Government at a regional level or from innovation point of view. And I think it's important that we understand a little bit more as to what help you're looking for. So you can use info@industrywales.com, and we'll try and signpost you. We don't deliver, we don't sell, but we'll try and signpost you in case there's some help that you require to maintain your business as it is today in the current circumstances. I do want to make one last comment on that one, is that I'm a little worried about sector-specific solutions. And I think a lot of the solutions in the future will be cross-sector activities on it. But of course, I do see that each sector right now is in a very different position as regards its market and its volume and its demand. So please link up if it's not innovation that you're concerned about there, where Astute will certainly be able to support you on, particularly the thinking they'll be able to support you on. But please link up with you if there's some urgent issue that you need some support on. I'm going to move on to the second question, which is about opportunities existing to align the Astute offer to the future of the manufacturing, future for Wales, which is now being launched by Welsh Government and known as the Manufacturing Action Plan. I can see Andy Rees from Circular Economy on here, and Andy's very much involved on this one here as well. So I'll say this very brutally. The Manufacturing Action Plan is to ensure that every part of government understands the importance of manufacturing and that they're doing everything they can to support it's good, right? So we're looking to progress that there. But as a question, Gavin, I'm going to come to you first on answering that one.
Yes, I was really pleased actually to see the strong emphasis in the manufacturing for the future on connecting the research in our universities with industry, enabling the development of capacity, capability, and those increases in productivity that we need to see within industry. And Astute, as we've seen, it enables this collaboration and has demonstrated significant success in applying academic expertise to industrial problems. I was also extremely pleased to see the focus on a green, circular, and low carbon economy within the strategy areas that I'm passionate about. I lead the Circular Economy Research Innovation Group for Wales, which has got all universities in Wales represented on it. And again, we have the expertise within Astute to help Welsh businesses lead the way in this area.
Thanks, Kevin. David, do you want to come in on that one question there, or shall I move forward? Because I know we're getting tight on time. You're on mute, Dave.
Nothing really to add to that, I don't think.
Okay, let's move forward on to some of the more harder questions. I think question 3 is, well, give us the measurable financial impact and value that Astute can have and provide to a business. Now, I'm going to throw this back to Hans first to give us sort of evidence based on it, and then I'd like to make a quick comment on this one.
Thank you, James. The only real evidence we've got, which has been independently collected, is the evaluation of the first phase from 2010 to 2015. And the current phase, this evaluation hasn't been done yet because of the schedule and the timing, not because it's something which was planned. So in the first phase, we generated basically £8 of economic impact for £1 in public expenditure. And that's quite a significant achievement. So overall, we achieved that £200 million of economic impact as evidenced in the final review report as published. So that's the only evidence we've got. We know anecdotal evidence of impact. We are collecting jobs created and naturally that carries economic impact measures against it, but this hasn't been accumulated and independently assessed yet. So we can't publish numbers here yet. James.
Yeah, I always find this one here is two sides to this one here. Of course, there's evidence on impact because EU-funded things ask for evidence to the nth degree, much too much of your frustration as to what that is, so that there is financial impact evidence in here. So, but you as a business have to see that impact at the end of the day. And in actual fact, what I recommend in here is that you challenge your own thinking. You challenge the thinking of your staff in using these type of support mechanisms on this. ultimately the benefit and the value only comes down to your bottom line, whether that's volume increase or whether it's margin improved or whether it's skills developed, etc. These activities enable you to do all three of those, but the benefit comes from your business realizing that in its bottom line itself. Question 4, what support is available to automate manufacturing processes? I'm going to start with Mo on this one.
Yes, thanks, James. I'd like to think that the examples we gave today gives you an idea of what support is currently available. With the particular cases that we highlighted, both in the automotive sector, analytical equipment, and in particular the video of that we saw from light ladders. I think that's prime examples of the kind of work that we do with industry in terms of automating their manufacturing processes. The scale and scope I mentioned earlier about co-creating and co-designing projects with industry. And the scale and scope can vary considerably, as you saw with light ladders, full implementation, going from a needs analysis, understanding requirements, all the way through to synthesizing and implementation as well. So it does vary. The scope of the project will vary from one case to the other. Just as another example, currently we're doing a joint working with another program supported by Welsh Government on life sciences, where we're looking at the manufacture of a device to help COVID patients in intensive care. And this electronic device is currently manufactured predominantly in a manual assembly line, but we're looking at the introduction of robotic technologies there. And that really is just a scoping study, just to say, okay, well, is there opportunity? What's your current level of automation? What's the future potential for automation? And what potential the routes you can go down? There's no actual implementation per se in that particular project, so it's simply a scoping study. Sometimes we do the carry-on work within ASTUTE, but other times we point people in other directions to other programs, or we might even just do some joint activity through another funding scheme. Just an example of previous work we've done. We started off with a feasibility study in ASTUTE, and then we ended up doing a KTP, Knowledge Transfer Partnership project, with the company afterwards, because that was the right thing to do for that particular issue that we were looking at. So I hope that gives you the range of activities we'll be doing in terms of automation.
Thanks. We've got a few people that are going to come on this one. I think it's quite a key one. Let me just say straight up from my background on this one here is automate the right thing.
Yeah.
Know what you want to automate first. Right? What is the significant issue? And that means there are some pre-processes on what you need to do, or some thinking you need to do on that one. Don't always automate what is easy to automate, but automate the right thing, and then automate it, of course, in the right way. Dave, I don't know whether you want to touch on some of the simulation stuff that you do on that. You're on mute, Dave.
Not at this moment, James. No, I don't think I need to add to that at all.
All right, hands over to you.
Thank you, James. Naturally, automation can take a wide range of things, whether it is a human-machine interaction, whether it is AI-driven automation, whether it is robotic type automation. So key is, as James said, the right thing needs to be automated, but we've got a wide range of expertise in being able to do this, whether we work with computer scientists, data analysts, and so on, whether it's about visualization of data. And as Paul has pointed out at the beginning as well, we've got a digital market supply chain project up and running now, which is the only test bed in the UK on this field, where we try to automate marketplace and supply chain creation, which becomes a dynamic ecosystem to deliver solutions for the customer. So automation can take many aspects and many implementations.
Great. I'd love
to... Sorry, James, I was going to say, I'm just reminded when you were speaking of the Ingersoll engineers, we were talking about Asia, which is analyze, simplify, integrate, and then automate.
Yeah,
I think that's always a good process to follow. Yeah. Otherwise, if you're automating the wrong thing, as you say, before you simplify and integrate, you can actually make things worse.
yeah. I think there's a lot of things in here. I'd love to tell you about the story of the first robotic line making radiators built in 1983 in Welsh. By the time it got to 1988, and I was arriving on the scene, of course, they were replacing robots with XY tables, because actually it was a simpler, low-cost approach to it all. It was more reliable in those days as well. So there's a lot of history on this one here about how you do the assessment on what you need to automate as a priority on it. Now, it takes us into another question, which is inevitable, that the investment for automation will increase, and therefore this is going to be a significant sum of money, and that we need to be very prudent on. But are there support and opportunities available for investing in manufacturing equipment to decrease headcounts in certain areas? I'm starting with you again on this one, Mo.
No, that's fine. Yes, thanks. I've got to do something here today. Yes, I mean, I think we've got to remember, I think that's why I like the light ladders example, because it was about automation, robotics, welding, and so on. And so you could actually, reduce headcount in one area, but actually they've increased the headcount in total. Okay, so it's given the opportunity to increase capacity and increase manpower and woman power within the organization. So we are there to help organizations enhance their capabilities and capacity to increase productivity. So that's very much what we're about. But our ethos is also about fair working, and I think that's part of the manufacturing future for Wales as well. Fair work is important. So we may decrease headcount in one area, but we're looking at where opportunities to relocate the workforce in other areas. But also we want to enhance the skill base as well. Okay, because with increased automation, we need different skills to traditional skills. So we need to train people. Now, ASTUTE is not involved in training per se, but we can direct organizations to training opportunities as well. So we want higher skilled and better paid people as well. So I think that's important. And just to remember, in terms of our formal targets, it's about, in terms of the funding body, it's about new processes, new systems, and new products introduced into the marketplace, but also the number of jobs created. Okay, so number of jobs, upskilled jobs, I think is a key thing as well, especially going forward into the future.
Thanks, Mo. Again, Signal, if you want to come in on this one. I think we need to take this a couple of different places. There's no doubt ASTUTE can't give you money for investment or manufacturing. Positioning that, what it means is working out what you need to automate and how you might automate it before you make the decisions to spend the money would be sort of ASTUTE's type of role in that process. There is support out there. I'm going to take the skills one most just spoken about, the flexible skills partnership activities, both on digital and engineering and manufacturing, would enable you to do some support work on it. When it comes to investment, there is support for investment on these issues. Now, it's strangely the way the question is written is quite deliberate, I think, which is, is there money available even though we're reducing our heads? Of course, we're looking for a productivity and competitive improvements to increase volume so that sales go up. But there's now a much better understanding that we can't just seek jobs. One job counts the same as the other job. And we've been able to explain over the last few years that as we automate things, that the level of job is improving. The number of jobs may reduce, but the level of job is improving, and the reward of that job is improving. And that means the job is sustainable, but also is of economic benefit. So there would be projects, there would be funds around like the EF fund that would enable you to invest in facilities and capital, etc. So again, by Welsh Government or your LGAs, please reach out to understand what funding is available for investment in equipment. Moving on to question 6, the scale-up support. What manufacturing scale-up support is available for biotech startups looking to sustain or to support sustainable circular economy manufacturing? And I've got a couple of people down here. I'm going to start with Gavin on this one.
Yes, I'm really happy to answer this one. So I can focus on the kind of the sustainable circular economy side of things, and ASTUTE can help businesses innovate and embed circular economy principles into their operations. So our materials expertise can help companies identify opportunities, say, for using recycled materials within their products. which have the appropriate properties that are still needed for that product. Colleagues in Cardiff can help with the development of resilient and resource-efficient manufacturing operations and supply chains. Our computer modeling expertise can help reduce risks associated with the design and development of new circular products through an enhanced understanding of the complex processes, as we've seen in the presentations. And lastly, which links to Andy Rees's question in the Q&A as well, life cycle analysis. One of the things that what companies need to do is to reduce their emissions and try and reduce their scope 3 emissions. Life cycle analysis is something I work on. I know colleagues in Cardiff work on as well, and that helps companies identify the environmental impact throughout their supply chain and throughout how their products use the entire life cycle of their products, and then focus on those areas of where they can reduce emissions and opportunities for making their product more circular.
Thanks, Kim. Now, I'm conscious we've only got 5 minutes left, and we already asked for the extra 15 minutes because we knew we were going to be out of it, and we can see a large number have stayed on. So I'll push on questions at the moment on that one there. I think that last question does link a little bit what Paul Pereira put in there. And Paul, as you've seen, I think we need to have a separate conversation on how we take the next level of scale up on these things. And there's no doubt scaling up is a difficult one for companies right now. And so we perhaps need to take that separately. Question 7 is, can innovation assist businesses overcoming challenges in this area? I think we can answer this pretty quickly, and I'm going to do it myself, just to give you all a bit of a relief. Yes, innovative thinking overcomes challenges. Discussions, one of the things COVID-19 taught us on medical devices and PPE was put the people in the room, and the innovation starts happening. One of the issues we have with remote working is innovation stops happening. You've got to reach out, see things about IP. And I know worrying about IP and protecting IPs is very important. But actually, if that stops you having innovative clustering discussions, it's a risk for your business. You will never know really what's going on or the opportunities that are out there. So I'm going to answer that one very briefly. But we've got an astute specific question here, Hans, which is, are there confidentiality agreements?
Very key is that every project will have a very detailed project proposal which outlines the work packages, the contributions, and that is accompanied by a collaboration agreement. The collaboration agreement is a contract where everything is nailed down, and including confidentiality, IP, and background IP, foreground IP, and exploitation of the IP. So it's key that, and this will be discussed for each project individually, and each project will be accompanied by one of those. So yes, everything we do is commercially confidential.
Yeah, likewise, I teased Dave earlier on about showing the 3 CFD analysis. Actually, what he showed you was the bit that didn't make the difference. The bit that did make a difference is under confidentiality agreement with our company, because that's the unique thing for it. Dave, I don't know whether you're off mic there, so did you want to come in on that? You're on mic now.
Okay, yeah, that's precisely it, James. I think that is the issue of confidentiality, and as I say, the case study was chosen so that the crown jewels were not revealed, essentially.
Great. Okay, we're moving forward now to the last question. Unfortunately, we will finish on time here. What support funding is available to support the drive of manufactured goods into a more sustainable product? One volunteer, and then I might chip in at the end. Let me just chip in then on this one here. I put this in a question, Marsha's question in here as well. I'm not certain that, we need to think about our carbon problem, our competitive problem, our circular economy problem. I'm not certain that's the right way to think on these things. And actual fact, all the things that you are doing to drive your business forward as competitiveness should ensure that the carbon issue and the circular economy issue and the cost issue and the waste issue are addressed. So actually, when you approach waste or continuous improvement, if you want to look at the other side of this one here, is you are dealing with all those different issues today. The innovation enable support mechanisms, of which ASTUTE is a major part, are significant in that area, but as well as bringing that cultural and thinking change within your organization to challenge the way that you're considering these issues itself. ASTUTE funding is available. That is not a window that will remain open for much longer. And I can see MADE Cymru on here. I can see the SMART programs on here. All of these have been EU-funded programs. We very much are pushing to ensure that we have, of course, lessons learned, continuous improvement, a new phase of this enablement occurring. But this window is closing. And I would really recommend this morning that you reach out to the ASTUTE team to just bring the issues of the day to them and see what they might be able to address. I thank you ever so much for your time today. Appreciate to the panel as well for your input. Rian in the background has done all the hard work on this. We give you our thanks, Rian. I wish you the best, and I'm sure we'll be in contact in the near future. Take care.
Thank you. Goodbye.